This is a continuation from the motions of a charge in a uniform magnetic field. So we have seen in the two cases that when the charge is moving parallel to the field, it does not experience any magnetic force. Second case is when the charge is moving perpendicular to the magnetic field, then the charge will move, in a circular path. And now we shall see in this third case, when the initial velocity of the charge moving in a uniform magnetic field, let's say it makes an angle theta with respect to the field as shown in this figure. So this is my uniform magnetic field B, and this magnetic field, let's say it is acting along x-axis. Now suppose this is the velocity of the charged particle, and this velocity it is making an angle theta with respect to the field. Okay. Now this velocity v can be resolved into two velocity component. One along x-axis it is v cos theta. Another along y-axis it is v sine theta. Okay. Now out of these two velocity component, okay, which velocity, right, we will see one by one here. Due to this v sine theta and v cos theta, what happens to the motions of the charge in a magnetic field? Okay, so now this parallel component v cos theta, right, it will not show any, magnetic force to the charge. So that means because of this component, then the charge will be moving along the same as the directions of magnetic field, because it is parallel to the field. Okay. Now, but due to this perpendicular component v sine theta, what will happen? Okay, we have seen before that when the velocity is perpendicular to the magnetic field, then the charge should be moving in a circle like this. So here, because there are two velocities, one due to v cos theta, another due to v sine theta. So because of v sine theta, as I've said, the charge will be moving straight. But due to this v sine theta, now the charge will be moving, in the form of a circle, like this. So as the charge due to v sine theta move that way, then this v sine theta, right, will try to, move in a helix like this. So I can see here that the motions of the charged particle, when the angle between the velocity of that charged particle with the magnetic field is theta, then the type of motions that the charge will perform in this case, right, it will be this helix. Okay, we call this as a helix. So a helical motion it is shown here. Okay, so I hope this is clear, because of v cos theta the charge is moving straight, because of v sine theta the charge is trying to move in a circle, because these two components are acting right at the same time. So that is why we have this type of motion, or this type of helix. Otherwise, if there is no v cos theta, then the charge, right, will be moving in just one circle only. But the charge at the same time is going, so this circle also is going along with the component velocity v cos theta. Okay, so this is the third case about the motion of a charge in a uniform magnetic field when the angle between the velocity and the charge is 90 degrees. Okay.